matrix multiplication. This can be a little tricky when we get into actually multiplying two matrices together. But we start out with multiplying scalars, and scalar is defined for you right there. You can multiply a matrix by a real number called a scalar. So in the example below, what's your scalar?
3.
3. So all you do is multiply each entry of the matrix, 3, 5, 2, 8, by your scalar of 3, and you end up with 9, 15, 6, 24. That's it for multiplying by a scalar. Okay? Now we'll get a problem like this. Simplify the expression. The entire first line, or actually, I give you all of this information. Simplify 5a minus 3b. Capital A and capital B are representing matrices. Okay, they tell you what matrix A is, and they tell you what matrix B is. So all of this information above here is given to you. So basically, we are just understanding what a scalar is. All right, so in the original problem, 5 is a scalar and 3 is a scalar. And then it becomes a subtraction problem. Okay, so when I multiply matrix A by my 5 scalar, I end up with this matrix down here. All right. Now you could do this one of two ways. You could either make 3 your scalar, which I did. I multiplied everything by positive 3 and got this. Or you could multiply everything by negative 3, but that would make this what?
Positive.
An addition problem. Okay. So either way, you get the same result. And then you just do what you did in last night's lesson and subtract them. 10 minus 9 is 1. 15 minus 0, 15. Negative 35 minus 18 is negative 53. 5 minus 8, negative 3. 20 minus 24, negative 4. And 25 minus 6 is 19. Question?
Wouldn't the negative 3, like once you figure out it's a negative?
Right here?
Like, no, for the, like right above that, wouldn't it be, once you multiply all of them in there?
I multiplied all of them by positive 3 and kept it a subtraction problem. If you multiply them all by negative 3, that's fine too, but you make it an addition problem. Because you're taking that negative with you, so what are you left with? An addition. Okay, either way, you'll get the same result. Solve this matrix equation. That's 4 capital X, capital letters are representing matrices. So we are trying to solve for matrix X. So 4x plus 2, 2 is your scalar, times 3, 4, negative 2, 1, equals 10, 0, 4, 2. So here's my original problem. And solve for X. Alright, so the first thing I do, just like you're solving any equation, you need to simplify or make sure both sides are simplified. Here, the left side is not simplified because I can multiply this matrix by that scalar and end up with 6, 8, negative 4, 2. So once you get here, both sides are simplified. You can't do anything else to the left or the right. So you solve it just like any equation. What do I have to do with this matrix? Subtract it from both sides. So I'm left with 4x on the left, and when I subtract it from this one, I should end up with 4, negative 8, 8, 0. 4x equals 4, negative 8, 8, 0. Now, to solve for x, you can either divide by 4 or dividing by 4 is the same thing as multiplying both sides by 1/4. And since we are discussing scalars, that's why I multiply both sides by 1/4. What would your scalar be? What's your scalar? 1/4. Okay? So, remember, a scalar is multiplying a matrix by a real number, not dividing by a real number. So that's why I multiply by 1/4. But if you want to think about dividing each entry by 4, that's fine. You're going to get the same result. So, a fourth of 4 is 1. A fourth of -8 is -2. A fourth of 8 is 2. A fourth of 0 is 0. So this is your final answer. Good? Okay. Now, the next part, this is where it gets a little bit tricky, or it can. Multiplying two matrices. The first thing I would do when I'm multiplying matrices is determine whether they can be multiplied or not. To do that, just write out the dimensions. So this is a 2 by 2 matrix, right? And this is a 2 by 2 matrix. When we added and subtracted matrices, we said they had to be the same type of matrix. You can only add a 2 by 2 to a 2 by 2. You can only add a 2 by 3 to a 2 by 3. Okay, in order to multiply matrices, you must have the same number of columns in the first matrix as the same number of rows in the second matrix. So this is a 2 by 2, write that out. This is a 2 by 2, write that out. This is representing the columns of the first, this is representing the rows of the second. They got to be the same. So if these two inside numbers are the same, then they can be multiplied. And your resulting matrix will be the outside numbers. You'll end up with a 2 by 2. So if I gave you a 3 by 2 matrix and asked you, can that be multiplied to a 2 by 5 matrix? What's your answer?
Yes.
Yes. The inside numbers are the same. The number of columns of the first is equal to the number of rows of the second. And your resulting matrix is a
2 by 2.
3 by 5.
3 by 5. Okay? Now the steps in multiplying are listed below. I used the rows of the first and the columns of the second. So to get this first entry, look at the highlighted numbers. Okay, I took the first row. What's the location of this first entry? It's in the first row and first column. So I have to use the first row and first column. That's how I get this first entry. I take -1 corresponds with -3. I multiply those together. And 0 corresponds with 5. I multiply those together. And then I add the result to get 3. Does that make sense?
Also like a 2-step column.
Mm-hmm.
Good.
So how would I get this -3? I mean, where's the location? It's in the first row, second column, right? So I have to use the first row, second column. -1 corresponds with 3, and 0 corresponds with 0. So you multiply -1 and 3 and add 0 times 0, and you should get -3. We're following this? Yes?
I'm confused.
Okay, let me keep going with the last two and see if it makes more sense. All right, to get the last entry, or this entry, what's its location? It's in the
Bottom row.
second row,
Second row.
first column, right? So I use the second row and first column. 3 and 3 correspond, so I multiply those. -4 and 5 correspond, so I multiply those. And then I add that together, I should get -29. And to get the last entry, it's in the second row, second column, so I have to use second row, second column. We're always using the rows from the first one and the columns from the second one. So 3 times 3 plus -4 times 0 gives me 9. Got it? Okay, let's go through it one more time. And it may be easier to see the highlighted one. Okay? To get the first entry, what's the first entry of the first row? -1. What's the first entry of the first column? -3, or second matrix first column is -3. So those two are corresponding with each other.
Right.
So you get +3. 0 and 5 are corresponding with each other because they're the second entry. Second entry of the row and second entry of the column.
So you
Okay, I get
just,
it.
you multiply it by,
Corresponding numbers.
Yeah.
And then you just add them together. So let's make sure we understand this. To get this entry, -1 goes with 3 and 0 goes with 0. That's how I get this. Because it's the first entry and this is the first entry of the second column. Okay? This is the second entry, this is the second entry. We'll try another one. Okay?
because you're like speaking Chinese here.
All right. Next.
Hold
Hold on. Let me see.
Sounds like mathematics to me.
I get it, it
All
just
right.
takes.
Now, let's look at the next example. This one just talks about whether two matrices are defined. Can they be multiplied to each other? Can A and B be multiplied? The answer is yes, because matrix A is a 3 by 2 matrix. Matrix B is a 2 by 2 matrix. Inside numbers are the same, your resulting matrix would be a 3 by 2. Can B times A, is B times A defined? So if you reverse the order, you end up with a 2 by 2 and a 3 by 2. Can those be multiplied?
So A, you
No.
have to take the row, and B, you have to take the column.
The first matrix that comes first,
You take the row.
you take the row, and you take the columns of the second matrix when you're multiplying. Here you're just trying to find out if they can be multiplied. So since these two numbers are not the same, the middle numbers, they cannot be multiplied.
Okay.